I'm going to drop this for a second so that we can see. So our learning target today is discussing that we can determine the relative frequency and or the probability of any given situation. So if I have a multicolored chip, right? So I have red on one side and tan or yellow or whatever you want to call it on the other side. I'm going to place a wager. So I'm going to randomly draw one of your names from here. You know what? You popped out, so Divine, you in here yet? Divine's not in here. Too bad for him. Isaiah, would you like to wager with me? I will wager you one of any of this, Sucker or Hershey Kiss or Starburst, that you cannot guess the right color when I flip this. You have a 50% chance, you realize. So, would you like red or would you like tan?
I'll take red.
Tan. You lose. No candy for you. You know, I'll do this a couple more times. Katie, what color would you like, red or tan? It's red. Sorry about it. Bella, what color would you like, red or tan? Red. Sorry. May the odds be ever in my favor, apparently. Oriana, red or tan?
Red.
Red? Tan.
Potatoes.
Potatoes. You guys are not doing well. All right, one last one with the coin. Thomas.
Oh yes.
Red or tan?
I'm going to choose tan.
Tan! We got a winner! All right, Thomas. You may pick your prize. Now, I have this colored spinner. So, you have red, yellow, purple, green, and blue on here to choose from. I'm going to wager 3 of any of these Starburst, Hershey Kisses, or Suckers. So, Bayla, what color would you like? Green? Ooh, you won! Alright, Bayla. Pick 3 of any of those. You may share if you would like. Cassidy, what color would you like? Yellow? Oop, not a winner. Sorry. That is sad. Zach, what color would you like? You got red, yellow, purple, green, blue. Blue? Right on the line, too. That'd be tough. We'll do one more with the spinner. Karina, what color would you like? Purple. We come up with blue. Sorry, not a winner.
I said blue.
Now, I have my die. How many sides are on here?
6.
So you have 1 through 6, right? So, Layla, 1, 2, 3, 4, 5, or 6? 3?
Oh, okay.
Cool, 3. Layla, now I forgot to mention, on this guy, I'm wagering 4. You get to pick 4 of any of these. Let's see who our next participant is. Eminal,
Oh, God.
1 through 6. What do you want? What do you want? 1 through 6.
The Price is Right 1.
1,
I need my punches though.
2. You are not a winner.
So close.
Eli, what would you like? 1, 2, 3, 4, 5, or 6?
1.
1. It's got momentum. 4. Sorry, Eli. All right, we'll move on. Big money. I will wager 5.
Oh, yeah.
5
I'm in this.
Suckers,
Big mic.
Starburst,
Cash mic. Can you put
or Hershey Kisses.
back in? Oh, I want
No. And we're going to discuss that later. Now, Bella just asked, can you put the other people back in the stack?
No.
Now, Brennan, you just said, I'm in this. What do you mean you're in this?
I'm like one of the only ones that hasn't got
Your card is left in the stack, right?
Yeah.
So what are you determining about your likelihood of being drawn out of the stack?
I'm like really
What-
likely.
So compare that to when I was flipping the coin. How likely were you when I was flipping the coin to get drawn?
Like 1 in 20.
Like 1 in 20, right? 'Cause we have about 20 kids in the class. Now, there are 1, 2, 3, 4, 5, 6, 7, 7 because that's the class name card. There's only 7 cards left. So Brendan says, oh, I'm in this because he has a very high chance of getting drawn now. Brennan, you are literally the next card. Now I have a spinner numbered 1 through 10.
No.
Oh, no! Brennan, pick a number 1 through 10. 5. You got 1.
That's a horrible spin.
Okay, we'll spin again. 9. Look, I'll even give him a third spin. Still not his number. Who's our next participant? Luke. Ah, not
Not
me.
here. I'll take it.
Crystal. 1 through 10. 7. 2. I'll even give you a second spin. 3. I'll even give you a third spin. 4. Not a winner. All right. Big money.
Oh, cash money. Cash money. The whole.
The entire bag.
What?
The entire bag of suckers. Franny.
Oh, Franny, go.
Franny. Franny. I need you to pick a card and suit. 3 of diamonds.
Oh my gosh.
Franny's looking for the 3 of diamonds. You get 1 pick. The 3 of clubs.
Oh, so close.
The wager carries on. Entire bag of suckers.
Do this with the whole class.
Ethan Bunger.
Okay. Okay.
What card?
That's true.
King of clubs. 6 of diamonds. Not the king of clubs.
Mr. Hudson, are you prepared that if somebody does win,
Yeah,
you're
what
going
if
to
someone-
Oh, don't worry. I have math on my side, Miss Jump. What card would you like to
It's a 1 in
choose?
52 chance.
What card would you like to choose?
No one that comes out.
What card would you like to choose?
I'm doing like 6 though. King of clubs.
6 of clubs.
6 of clubs.
6 of clubs. 6 of clubs. Pick a card.
75 cards in here.
52 to be
Yeah,
exact.
52.
King of diamonds.
God dang it. She got a king and I
Divine, I can see that your purple card is next on the stack. What card would you like to pick? Terrible shot.
Number 4 something.
4 of what? There's clubs, diamonds, spades, and hearts. 4 of diamonds. Pick your card. Shine bright like a diamond. What'd you get? Nope. 9 of diamonds. He did get a diamond, but he did not get the 4. And is there anybody else that has not had a chance? Yes, you did. All right. Why was I so confident in wagering my entire bag of suckers for that last situation? Why was I so confident that I'm willing to place such a hefty wager? Eminal?
Because you knew it's going to be less likely to win.
Now, why did I know that you'd be less likely to win?
Because the number of cards in there.
Because there are a lot more options. There's a lot more outcomes that are going to affect your probability of winning. Because when I have you choose 1 card, there are 52 cards in a standard deck. So if you're choosing 1 specific card, like King of Hearts or Ace of Diamonds, or 1 specific thing, you only have 1 chance out of the 52 cards. And we could calculate that percentage. That is under a 2% chance. Less than a 2% chance of winning that bag of suckers. So this is exactly what we're discussing today. We're talking about likelihood and probability. This is one of my favorite things to teach, especially because how I get to start the lesson and give you guys a chance to win some things. So when you have a friend, let's say your younger sister, younger brother, somebody, you ask them a lot of questions and they say probably to every question. Are you going to go to practice today? Probably. Do you want to go to school? Probably. Are you going to eat dinner? Probably. Will the earth go around the sun? Probably. Tigers will fly? Probably. You are going to write a best-selling novel? Probably. It will rain this week? Probably. Your team's going to win the big game? Probably. What does probably mean? What? Like maybe, right? So probably refers back to probability. Because your probability is the likelihood of something happening. So when we look at the weather and they give me a percent of chance that it's going to rain, that's the probability based on computer models. They say this is the likelihood of it raining compared to it not raining. So come up with a better way to describe each of these situations. So take a minute on your paper next to it. How would you answer these questions? Will the Earth go around the sun? Well, hopefully you know something about our solar system there. Tigers will fly. We are not living in a fantasy world. We are stuck with the physics of our world. So, Layla, if I asked you, what's the chance that the Earth will go around the sun?
Probably very likely.
Yeah, very likely, she says. Very likely. Brennan, what about... you stepped out of the room. Karina, what about tigers will fly? How would you, if somebody asked you, hey, do you think tigers will fly? Is that likely? Is that, like what? So you would say not likely? Would you say not likely or would you say not possible? So is it possible that the tigers will fly? Well, that would be falling with style. That would not be flying. So we can answer this as not at all possible. Possible? Possible. Zach, what is the likelihood? How would you answer that you will write a best-selling novel?
Not likely.
Not likely? Why is it not likely? Do you like to write?
No.
So there you go. Because Zach does not like to write, it's not likely that he's going to try to write a best-selling novel. Cassidy, what about it will rain this week? Have you looked at the weather for the week? This next week looks fantastic. Highs in like about 70% of rain is very low.
Yes.
Very low percentage.
I'm pretty sure.
So not likely. And your team will win the big game. Who's got a team with a game coming up? Anybody? Nobody? Bella? What do you think the chances are that your team's going to win your big game?
As likely as not. Like.
So
Is
like
it like a 50-50 chance?
so like 50-50, or we could say like even chance. Do you know anything about the other team? Do you know if they're better than you or worse than you?
We're probably better than them.
So even chances maybe giving you guys a little bit of home team advantage or whatever, because you're giving yourselves an even chance. If you know the other team is better than you and you still say even chance, you're kind of building your team up. But why is probably not a good word? Why is probably, like, really it's a terrible word to describe things? Thomas?
Showers likely in the afternoon.
Sorry.
I better bring my
I
umbrella
wish I
today.
could mute this somehow, but I'm just going to turn it down so we can talk.
What's this? Congress certain to pass new tax law. That's good.
Is a bad word, not a good word, because
Still in a slump. Playoff spot for Wolves impossible. Better luck next year, Wolves.
the sun will go around the earth. It's
Scientists say another earthquake is as likely as not. Wow.
Yeah, like everything we know says this is
Economy
gonna happen.
unlikely to
Probably
recover this year.
leaves doubt, right? It probably will or probably won't. Like, probably has an entire spectrum of whether it could or could happen. If you ask your parents, hey, can I go spend the night at a friend's house this weekend? And they say probably, you're like, what, is that a yes or is that a no or is that, like, what is that? So instead of using probably, we use descriptor words like impossible, unlikely, as likely as not. This is our even or our 50-50. Which of the probabilities that we started class with, which of those were as likely as not? The coin, right? The red versus tan. You had two chances, and you were choosing one of them, you had as much chance to win as you did lose. Showers likely in the afternoon, so likely would mean it's probably going to happen. It will, like we could assume it's probably more than a 50% chance. 60 or 70 or 80% chance would be likely. Congress, certain to pass the new tax law. Certain tells you it's going to happen. Like Thomas said, the Earth is going to go around the sun unless something crazy happens, like a giant meteor. So we're certain the Earth is going to rotate the sun unless something crazy happens, but that would be like an outlier situation. So these are the words that we like to use. These are the words in our spectrum of probably. I'll be curious if anyone in the afternoon wins the bag of suckers. So determine the word that you would assign with each of these situations. So you will go swimming on a hot summer this day. There will be children wearing blah, 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 blah. We can probably work through this together. So Abby, what word would you assign to you will go swimming on a hot day this summer? Yeah, likely. You think it's likely going to happen. So write that beside that situation on your paper. Ethan, what about there will be children wearing costumes on Halloween?
Certain.
Yeah, not necessarily that you're going to wear a costume on Halloween, but that children will be wearing costumes. There will be children in costumes somewhere. It is certain that that's going to happen. Franny, what about your hair will grow 5 inches in one day?
Impossible.
Impossible. That unless you have some kind of weird superpower where you can grow your hair really fast, which is not a very good superpower. That is impossible. You can flip a coin and land heads up. Crystal, what word would you assign to flipping a coin landing heads up?
What?
It's unlikely that...
As likely.
Yeah, it's an even chance. It's as likely as not. It's one of those situations that we would say has a 50-50 outcome. It's 50% this way, 50% that way. A student in your class will become famous next year. Eli, what do you think? That is unlikely. It could maybe happen, but it's not very likely that you will become famous as an 8th grader. So this is how we utilize some of these descriptor words. But better than descriptor words is being able to assign the math to it. So when we talk about the math behind it, this is not on your paper. So real quick, what word best describes the likelihood that 2 people sitting next to each other on the bus have the same birthday? We're talking same day, same month, same year. Ethan?
Like a 1 in 365, right?
Approximately 1 in 365.
Wait,
So
wait.
could it happen?
Yes, but there's also a little bit more math for that. In a group of 96 people, there's a pretty high chance. I think it's like 83% chance that you'll share an exact birthday with one of them.
An
If they're all around
exact?
your age.
Yeah, if you're on like the same.
Like so, if we all gathered at Forum,
Yeah,
like
7th
the
grade.
entire school, there's a pretty high chance that you at least share a birthday, not a birth year.
So it would be unlikely, but not impossible. Like the probability is small, but it's not impossible. This is not on your. This is not on your paper. We actually did a problem when I was in college, determining is it possible to have somebody else on Earth with the exact same number of hairs on their body. Here's how we calculated it. What is the maximum number of hairs for 1 square inch of your body?
800.
What is the, and so then we did the maximum surface area of your body. We did a bunch of approximate calculations. We determined that there has to be people in the world with the exact same number of hairs on their body. It would be impossible for every single person to have a unique number of hairs on their body. So that's just a really crazy idea to think about, that out there somewhere, it's likely that there is somebody else with the exact same number of hairs. Yeah, Isaiah.
Me and Lydia share the same birthday.
You and Olivia share the same birthday?
Lydia.
Hey, gentlemen. You with me?
Lydia.
Olivia Berry?
No, Lydia Vanderlei.
Oh, Lydia.
Like, the exact same. And we used to ride the bus together.
Yeah, so you could have been that situation. So I'm going to show
The
this quicker than they do. When we talk about the probability of an event occurring, we then need to assign some math to it, right? We need to assign some fraction values, and then those fraction values can be converted to decimals, and those decimals can be converted to percents. So on your paper, you have these all shown to you. It's a little blurry on your paper, so if you need to bold up some of those values. But when we talk about as likely as not, the middle of this probability range is when you have an even chance, that coin flip at the beginning of class, when you had a 1 out of 2 chance, that you're as likely to win as you are not to win. What about the color spinner? Where would that go in this spectrum? How likely were you to win? Were you more likely than the coin or less likely than the coin? Less likely. So we'd be somewhere down here working towards. Now, did you have a 1 out of 4 chance? No, you had a 1 out of 5 chance. So it'd be a little under that 1 out of 4. So color spinner. I'm just going to say color spin. What about the number spinner? What was your chances there? How many outcomes were there? Yeah, there were 10 outcomes and you could only choose 1. So that number spinner was even less likely. What about your deck of cards? How many outcomes were there possible? 52. How many did you get to choose? 1. So where would that fall? Very close to impossible, because you had a 1 out of 52 chance of getting that correct. That's why I was able to wager the entire bag of suckers. So if you think about the math, I'm going to approximate. Hold up. I'm going to approximate. If there were only 50 cards in the deck, and we think about 1 out of 50, that really becomes 2 out of 100, which we can make 2 hundredths. Sorry, I tried to make it 2 tenths. So that means that 2 times out of 100 times of me doing this, a student would win. How many times did I do the deck of cards for you guys? Like 3 or 4, right? Like,
4 times.
Yeah. So how many times will I do it in the afternoon class? Probably another 3 or 4 times. So am I worried about somebody getting it right?
No.
Not really. I'm not going to do it anywhere close to 100 times. And even if you do it 100 times, that doesn't necessarily mean that 2 people will win.
You're very
This
likely to get at least 1 person.
This is your theoretical probability. In theory, when I do this 100 times, 2 of you should win. But will that necessarily happen? No. What was happening when I was flipping the coin? The first 2 or 3 or 4 times, who won?
No one.
I did, right? Or I guess you didn't win. I didn't really win anything, but you didn't win. Was that what the theoretical probability told us should happen? No. Theoretical probability tells me that 1 out of every 2 times I flip this, you should win. So if I walked around the room, you'd assume loss, win, loss, win, loss, win. But that's not what happened, because theoretical probability does not always match up with what the experiment outcomes show us. Ethan?
I also noticed, I have 2 things. One about when you did the card thing with me. The reason I chose King of Clubs was because I saw it when you were shuffling. And I tried to...
I know, I saw that you were trying to anticipate where it would end up in the deck. Mm-hmm. So even with that advantage...
I think I was like 3 off.
Yeah, you still weren't able to win. Emmanuel, what'd you have?
Oh, I had another thing.
Oh, sorry, I'll come back.
The coin, when you flipped it, it was every other, it changed-ish. Like,
Yeah, so the outcome... So here would have been the advantage. If you guys had all determined, guys, we're all going to pick the same color. Just keep picking the same color. We'll talk at some point later. My buddy has this theory about the roulette wheel. If you know about the roulette wheel, there's like 2 greens, there's like a 0 and a double 0, and then the rest are red and black and they're numbers. So if you bet on a color, your outcomes will, like, of what you would win if you actually won that, would be a certain percent payout. But if you bet on, like, the green, because it's so improbable, there's very little chance of you winning, your winnings would be better because of that, like, chance of winning is so low. But every casino, every game at every casino is designed for the house to win.
Yeah, like when I played blackjack with Eli once, Eli and another one of my friends, I won most of the time when I was playing house.
Yeah.
You guys remember, and I was just sitting there with all the little chips we had. and
So
it was
when
like,
so when you think about Columbus as a casino, right? Hollywood Studios casino now, right? Whatever. Casinos are designed to take your money. So I'm not teaching about probability to teach you like, oh, go gamble, go wager. What I'm teaching was how to analyze a situation and realize what is the likelihood of a certain outcome. And when you go to the casino, if you think through the math, your likelihood of winning is worse than your likelihood of losing, and you losing is the house winning. The house always wins in the end. So you choose a flag design. So MI Olympics, right? MI Olympics are coming up. You're going to be assigned a letter, and based off that letter, you're going to determine a country. So when we look at these flags, these are 4 countries' flags. We say the probability of choosing a flag with a stripe is 1 out of 4, because I have 4 possible outcomes, and one of them has stripes on it. So what we do for probability is what we want, what we're looking for, over the total number of outcomes. So I want you off to the side here to write probability. Probability is what we want over all outcomes or all possibilities. So there are 4 possible outcomes here. 1 has stripes, gives me a probability of 1/4. We then can convert that 1/4 to 0.25, and from there we can say we have a 25% chance. So now we have this entire group of flags. First thing we need to determine, how many total outcomes are there? Well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So the group altogether has 20 possible outcomes. So when I set up my fractions of probability, they're all going to be over 20. So take a moment, determine your fractions for probability of a stripe, a triangle, and a circle. Now the circle fraction's already been given to you, but look through and determine why this is happening. Identify the flags that have what you're looking for. So you could circle, box, triangle, different things like that.
The green and red one doesn't look like it has a signal.
So if I look through and I'm looking for flags with stripes. This has a stripe. These have stripes. That probably we count as a stripe. Stripes, 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 stripes. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
So,
I got 12.
did you count the ones that
Check.
are?
Check if you highlighted what I have.
Okay, no.
Wait, could you just do 20 times 65? That'll give you exactly the number.
Yes, but we don't want to work it backwards. We want to work it forwards. So, flag with a stripe. There are 13 striped flags out of 20. That is how I got my 0.65. Because if we do 13 divided by 20, this gives me 0.65, which is why that's right here. So you could actually over here, I should have said that from the get-go, you can write your fraction over in the right area. And the percentage then, what's the percent? If it's 0.65,
65.
it's 65%. So, is this unlikely, likely, impossible, certain, or even? It's likely, right? It's more likely to happen than it is to not happen. So we say it's likely. It is likely that you would pick a flag with a stripe. Now I'm looking for a flag with a triangle. So I've got a triangle here. Keep going. I've got a triangle here. Triangle here. Triangle here. Couple triangles there. Couple there. One there.
Wait, that one right there is kind of a triangle.
Where? Ah, this?
Yeah.
Aha. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I could have figured that out. Eli?
Because
It says 50%. So you assume that since this has to be over 20, there must be 10 of them, but we want to check their math, and we did. It does come out to 10 over 20. What would that decimal be? But we already have 50% with the decimal. 0.5, and we can put the extra 0 on the end if we want to. I can check their math for flag with a circle. No, wait a minute. They gave me 1 out of 5. Are there only 5 total flags? No. They simplified. So if we unsimplify and we try to put this over 20, how many would be over 20? 4. Because when I look at my flags with circles, I've got here, 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 and here.
But we don't really do we need the fraction again?
We don't need it. I just wanted to show why. Like, there weren't only 5 flags. They had simplified their fraction probability. So then this would become 0.20 or 20%. So the likelihood of a flag with a triangle. Bela, what do you think? The likelihood of a flag with a triangle, not the math, but the verbal. If it's 50%, what do we use to represent that? So you can flip back to the front if you need. That middle, as likely as not, or we can just say that that is even probability or even chance. Which also a lot of people say that the chance is 50-50. You'll hear people say, oh, it's a 50-50, which means you have as much chance of winning as losing, or as much chance of getting what you want as not getting what you want. Yeah. Thomas, what about your circle? If you have a 20% chance, how would we phrase that?
Not likely.
Yeah, it's not likely, or we could say unlikely. It could happen, but it's unlikely. Eli?
If 50-50 were a probability, wouldn't it be 100%?
So that's not the actual probability. That's not 50 divided by 50. People just say 50-50 because this is 50 on like the win and 50 on the loss because it's like percent of win versus percent of loss. So I like your question. I love your question. This is not actually dividing. It's just a phrase that people say is 50-50. Thank you for asking that because that's that's important to clarify. If the probability of choosing a flag with only 2 colors is 0.15, what is that as a fraction and a percent? Now wait, 0.15. When I start making that a fraction, well, first we can make it a percent. I'm going to go left to make it a percent. What is this as a percent? 0.15 is 15%. We just move the decimal 2 places. It's 15%. But when I start making that a fraction, it's 15 over 100. Do I have 100 flags? No. Bella?
Well, we have 20 flags, so you do 100 divided by 20, and then do 15 divided by 20.
We don't divide by 20. What you're meaning is I want 20 on the bottom.
So you would divide by 5.
I divide by 5. Because 20 is my total group, my total outcomes, I want 20 on the bottom. To get there, we divide by 5. So I do the same math on top. 3 of my flags only have 2 colors.
Which ones
Boom, boom, boom.
What about which one? That yellow one with the triangle.
That has yellow, black, and blue. And white, actually.
I can't see them. Sorry.
Yeah, on your paper, you should be able to... Well, you can kind of see that one's darker than the other because it's printed grayscale. So you can kind of see that this is a blue and that's a black. That might be where your confusion's coming in. Any questions on how we determine that there are 3 flags? We want to make our fraction have a denominator that matches my entire possible outcomes. Hey, I want you guys to do me a favor. Without giving details.
I'm sorry, Mr. Invisible, but if you are not here before boarding is complete, I'll have to put you down as a no-show.
But I am here.
Who said that?
Sometimes I really hate being invisible.
But you can say it's possible to win an entire bag of suckers. Do not let them know how they would win it. Right? Because I want it to be a surprise. So that they walk in thinking that when I start flipping the coin, that they think that that's how they're going to do it. So,
Very likely.
no, don't say it's very likely because that would be a lie. I don't want you to lie. It's possible. It's possible. No, all I want you to say is it's possible to win. I didn't say probably. I said possible. Possible means it is not impossible. Is all that really means. So, airlines call a person who reserves a ticket for a flight and then does not board the flight a no-show. Divine, can I help with something? So, because of no-shows, airlines sell more tickets than a flight can actually seat. The airline actually overbooks the flight. So, this is a strategy so that they can make sure the plane is full. Now, what do you think they do with the people, like if they have too many people show up for the flight? Thomas? No, they won't cancel it, and they don't lie to people.
They just book them another flight. They give them another flight, like the next flight.
But what might they do with giving them a different flight?
Oh, they might give them give them like miles, like airplane is like if you have like a credit card for like Delta or something. I'm sure you can.
Yeah.
And
So
like you can use the miles for, or you get like a free like plane ride to like just a one way.
on our way back from our honeymoon, Brandon's totally right. On our way back from our honeymoon, my wife and I were in Florida, and we were about to, we were waiting on our flight, and they came on the loudspeaker, and they said, any passengers on flight, blah, 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 whatever it was, that are willing to wait 2 hours for the next flight to Ohio, we will upgrade you to first class and give you a free flight. They will give you vouchers for another free flight somewhere.
Wow.
Because they can't kick people off the plane. That's a very dangerous thing to do. To say, oh, you don't get to fly with us now. But what they want to do is try to convince people to not ride that plane and ride the next one that probably did not sell all of their tickets. If they know the next flight has open seats, they'll persuade you to take that next flight. So, an airline believes the probability of passengers being a no-show is 10%. They've done the research. They see that 10% of the tickets sold, they don't show up. So, 10%, 0.1, or 1 out of 10. 1 out of every 10 tickets sold, they don't show up. So, the airline overbooked these different flights. 210 tickets were sold for a flight that was 200 seats. Then 330 tickets had been sold for a flight that could hold 300 passengers. Which of these should the airline expect to have more empty seats if 10% of your tickets sold don't show up? So the first thing we have to do is figure out how many do we expect not to show up. Thomas, you know how to figure out how many we expect not to show up?
I think the one that has 210 tickets for the thing that has 200 seats, that's kind of like, that's inaccurate because it's supposed to be 220.
I agree if they were able to sell all of the extras. This just means they didn't sell all the extras. Only 210 people bought tickets. So that they probably still had 10 tickets available to be sold. So I agree with you. They did not sell their entire 10% extra. But what we have to do is calculate if 10% of the tickets sold. What does of often tell me to do? multiply, right? 10% of the tickets sold. Guys, 10% is the easiest percent to find. All we need to do to find 10% is move your decimal point over. So they would assume 21 of their passengers are not going to show up. That's what they're expecting, is 21 of their passengers are not going to show up. Which means if they sold 210 tickets and 21 don't show up, how many would show up? Well, if we do the 210 that they sold minus the 21 that aren't coming now.
189.
So how many open seats do they have?
11.
They would probably end up with 11 open seats. Same method for our flight that sold 330 tickets. We're going to say, well, if 10% of people don't show up, how many will that be? 10% of 330? 33. So I can take my 330 minus that 33. 297. How many open seats? 3. They'd only have 3 open seats. So even though this flight sold the entire 10% extra, if they assume that the 10% of tickets sold don't show up, they still only have 3 open seats. But if everybody shows up, then they've got an issue. Then they've got to find a way to get people not to fly. So this plane will have more open seats. No, we needed to get back because we had a ride that was coming to pick us up. So we just decided to go back. I have 2 minutes. No.
Oh, I'll do it. I want to try it
Wager
again.
still stands. Wager still stands. Now hold up. What is your probability of being chosen in this?
1 of 20.
How many people are here today?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know if I can count that fast. 19, 18.
I don't know. Sure, we'll go with 18. So what's your likelihood of being pulled out of this deck? 1 out of 18 or 19 or how many people are here. So if I pick somebody at random, I can't look because I know who the purple cards are. Divine. Pick a card. What are you going for? What are you looking for? 8 of what?
Ace.
Oh, ace?
7.
You gotta pick a 12. You want an ace or a 7?
I want a diamond.
So 7 of diamonds?
Yeah.
Okay, 7 of diamonds is what you're looking for.
Can I go?
No. That would be completely cheating. Cheaters.
Shatters.
Apparently I'm gonna have to come down here now. Pick a card. Ooh, 9 of hearts.
Wait,
I was going to guess 9 of hearts.
I want to try it again.
See, I
No,
want
I'm ready. I'm ready.
Abby, jump. Now, what's funny is this is in probability of me picking Divine again for the deck of cards and Abby again for the deck of cards. That's very unlikely. So we just had a very unlikely occurrence. So who knows? Maybe you're going to win. Maybe this class is the unlikely probability class. So what do you want to find? What do you look for? 6 of hearts. Any card.
Guys, it's really a
Any card.
2 of hearts. So she got the right suit, but not the right number. We are out of time, guys. Have a great day. I will see you later.
It was the one. Yeah, I will do it.
Sorry, we're out of time. Gotta let you guys get out of here.